Hello, everyone. My name is Maciej Aniserowicz. I came here from Białystok, and we will be talking about CQRS today. I heard that Dino learned you earlier this day how you should pronounce it, but it's not funny, in my opinion. I wanted to talk about CQRS for several years, but I waited until I actually used it in production in multiple systems, and it just works for me. This talk is called CQRS for Everyone. I will tell you why for everyone in a minute. This is the agenda of today's talk. As you can see, it's quite simple, and it's not the most important part of the presentation. The agenda is that we'll be talking about CQRS, which means Command Query Responsibility Segregation, and it consists of two basic parts. The read side, which you will see the demo of, and the write side, which you will also see a demo of. But the more important thing is the anti-agenda, so what we will not be talking about, because this talk is for everyone. Now, when you put CQRS in Google, you will probably see a lot of concepts like domain-driven design, like event sourcing, like multiple data stores, like NoSQL, and so on, like message queues, and we will not be talking about this today. Because to understand and to implement the core, the heart of CQRS, you simply don't need to know this stuff. And it's a lot, and it's quite hard to get it right for the first time, while the CQRS in itself is rather easy. When I tried to approach CQRS 5 or 6 years ago, and I put CQRS in Google, Google asked me, "Did you mean cars?" And it was the time when actually Greg Young and Udi Dahan, two very brilliant guys, started defining this approach, because it is not an architecture, this is not a design principle, this is an approach to writing software. But it's not something new. Bertrand Meyer, a very important person in the software development history, in the 80s of the 20th century, defined a principle which he called Command Query Separation, CQS. And Command Query Separation told us that a method, a single method, should not return a value and do something else. It should either return something or do something. Why? Because asking a question shouldn't change the answer, which is a very deep sentence, and I thought about it a lot, and it's good. Udi and Greg tried to take CQS, Command Query Separation, and apply it in modern technologies, modern languages, modern frameworks, and they came up with the idea that the method level is too low for the 21st century. They say that every component or even every service should either do something or return something. And this is CQRS. And after this introduction, can any of you tell me why this picture is here? I don't know how about people from other countries, but guys from Poland should get this. Any ideas? Oh yeah, this guy got it right. Police in Poland applied CQRS dozens of years ago. They drive in pairs. One of them can read, the other one can write. And this is CQRS in its purest form. And this is what we will be talking about. Because most of our systems, even today, after 5 or 6 years of CQRS being so popular, look like this. This is a diagram drawn on a tablet with the lowest possible resolution. If a diagram doesn't fit on this tablet, it's too complicated for me. So we have a single model, one big model. Some call it the domain model. Others call it the business logic model. And it works like this very often, that you just take your database diagram in Visual Studio, put it on Entity Framework Designer, and you have your model. It has nothing to do with the domain. It has very little to do with business logic. It's just your data generated as code, your database structure. And it is a very big problem, because we try to use this single model, this single set of classes, to answer some questions, so we send queries to this model, and we also try to tell it to do, should be this. And we tell it to do something, so we send commands. And a single model isn't fit for this purpose. It's not enough. And to do CQRS, we need to draw a line, which you saw before. We need at least two models. One of them will be read model, which is dedicated for fetching data, which will return data that are ready to be put on the screen for the user to use. That's it. If a user does something, then we don't use this read model anymore. We use our write model. And we use commands, or however we call it, to do some changes to the state of our system. And it really helps a lot with a lot of problems. And what problems we get when we try to read data from this single model? Well, the problems with read are that we try to do complex queries on this model. Even if it is entity framework generated code that represents our database, we could see after the launch what monsters can be generated using ORM, Object Relational Mapper. Be it an Hibernate on entity framework, it doesn't really matter. We try to use ORM to generate very complex SQL queries. And then we laugh at ORMs that they can't do it. And you know what? ORMs are not written to generate complex SQL queries. So what tool can we use to generate complex SQL queries? Our brains. Because me as a developer and all of you as developers are much better in writing SQL than any given ORM. We cannot expect a tool such as Object Relational Mapper to know everything about our data structures, about indexes, about the most commonly used queries. Simply, this is not their job, and we are abusing them. And then there is the very popular repository pattern, which can be found in almost every application. And I was asked multiple times why I hate repository pattern, but I have a dedicated slide just for that. And here you can see a screenshot of my daily workflow. When I was working as a freelancer, I was building some web application. And when a customer came to me and said that he wants some new feature to be implemented, some new button on a page, what I did? I opened my favorite text editor, which is Sublime Text, and I write my SQL query exactly how I want it. I know that this query will use indexes that I have defined, will fetch only the data, the columns that I need for this particular scenario, and it will do some efficient joins, because we sometimes can do manual shortcuts when joining tables without going through all the tables that are linked in the relationship chain. Then I open SQL Profiler. Then I open Visual Studio. And when this first SQL query that I was writing manually took me 10, 15 minutes tops, the process of translating this query to, I was then using a Hibernate, but it doesn't matter, any ORM, was taking 1 hour, 2 hours, sometimes even 7 hours. And it was horrible, because I wanted exactly this query to be generated. I didn't want anything else, because, like I said, it was using proper indexes. It was fetching me the columns that I really need, not something more. So I then opened my web application. I clicked on this button, and I checked in the profiler what was the query generated by my tool, by the ORM. And you might think why I didn't do this using automated testing. I'm a testing freak, I admit, but testing doesn't really help here, because if we try to automate these things and we try to write tests that will check that indexes were used, that not required columns are not fetched, and that no lazy loading is used during this process, then it will take not 7 hours, but 17 hours per query. It just doesn't really scale. So how I approached this problem, how I solved them, I will show you. It's not really that hard. The system that we will be working on right now is designed to show its users advertisements, like every other system in 21st century, but this is the only purpose of this system. So we have the advertisement class with ID, title, content, the isArchived flag, because we know that we don't delete any data from the database, we just mark it as not used anymore. And we have some advertisement, where is the cursor? And we have a picture. We know that we don't put pictures in the database, but we also know how people write code, and it often happens. We want to count how many times each advertisement was viewed. So we have add_view, which is linked to the advertisement and has some view date. We have a user of our system with just ID and username. We have a company, which has ID, name, a list of its customers, which is a list of our users, and a list of the advertisements that it defined. It wants to show these advertisements to these users. It's not really that comfortable. Okay, so what scenario can we implement using this system? The client comes to us and says that he was reading something about some user stories, how they should look like. So he tells us that as a user, when he enters the ads page, he wants to see a list of ads so that he can choose something to buy. He also doesn't want these ads to be archived, so he doesn't waste time on browsing not current ads. And he also wants to see how many times each advertisement was viewed so that he can predict what product will be popular soon and buy it. Then he was a user. Now I, as a developer, when using MVC, I'm creating my ads controller. I put a action, get ads on it. I get the user as a parameter. And I, of course, don't want to put any logic in the controller because it's bad. I will use repository for that, like it was doing something better. I have this repository, and I cannot create a method that is called getAds on this repository because it does more than that. This method would probably be called getNonArchiveAds with viewsCount, without pictures, because we have this requirement that we do not show pictures of advertisements on the advertisement listing. We only show pictures when someone sees a single advertisement page. So we have get non-archived ads with viewsCount without pictures for user. And this is the proper name for this method in our repository. Then we go and implement this repository. What do I do first? I write the query that fits my needs. I do it in 5 or 10 minutes. I just do a select. I select some columns. I do some joins. I do a simple subquery. I do some filtering. This is all the data that I need, and only the data that I need. Nothing else, nothing more. It took me 10 minutes. Then I try to do this in an Hibernate or any other ORM. I first do a query over. Then I do some joins. How to do joins? If I am frequent and Hibernate user, I will do it in like 10 minutes. And then I try to do the conditions, another 10 minutes. Then I try to do a subquery with which will count add views. Even if I am a frequent and Hibernate user, this is not trivial. It will take me probably another 30 minutes to write it and test. So we have now 1 hour for this. And then another thing. We do not want to select the pictures column. How do I do that in any ORM? It will probably take some time to Stack Overflow this, copy, paste, maybe create some more classes, maybe modify my model, and 2-3 hours have passed. And then we have some more requirements, and I was doing this for years on a daily basis until some little child in me told me that life is too short for this shit, and I threw will not be implemented exception. I then thought, what is the other way to approach this problem? Because I was doing it over and over again. I was wasting hours every week by translating raw SQL into an Hibernate queries, which should work the other way around. And Hibernate should translate my C# code into SQL, not what I was doing. But I knew exactly what queries I needed to make my system perform well. We can do it differently. If I already have my query defined, this is perfect. It took me 10-15 minutes to write, and it does exactly what I want. why don't I just create a simple view in my database? When I have this view will be a thin layer of abstraction over my data in my database. This is why this session is called CQRS for everyone, because almost every system can add some views in the database because they don't modify the data. It is just a thin layer that will allow us to fetch exactly the data that we need. So we have this view, and how our controller will look like. Our controller won't have any dependencies like repository or anything else. It only needs to be as simple as possible. And it can be as simple as possible by using a library called simple data. It's a very brilliant tool which represents our whole database as a single dynamic object. And simple data, I don't know how many of you know simple data, but if ORM is object/relational mapper, simple data has only the slash. There is no object relational mapping. It is simply generating simple SQL queries that I don't want to write myself because in this scenario, I only need select star from view, where, and some basic filtering. Simple data does exactly that. My controller takes a dependency on simple data, so on my database, and it's nothing wrong with that. This is the read side of my application. It should be as simple as possible. If I could use PHP here, I could. I tell simple data, hey, simple data, go to my database and find something that is called advertisements for ads page. Simple data goes there, and by convention, it looks at the tables. Whoa, there is no table with such name, but there is a view. So I will use a view to get data for the brilliant developer. And then I tell simple data, find me all records in this view and filter it, please, by user ID column. Simple data uses many conventions, and this is how I do filtering by a single column. So it will do select star from advertisements for ads page, where user ID equals this value. It takes, again, 5 minutes to write. So I have 10 minutes for my SQL query and a view, then 5 minutes to do this, and I'm done. Okay, so what is the takeaway from this? That it is really very simple to implement features that only represent some data on a page or in application. It's very simple. And when I started doing this, I got very big efficiency boost. Instead of doing one feature per day or one feature per 2 days, I started delivering 3-4 features per 2-3 hours. Because it was the hardest part becomes the styling, the HTML, the CSS, which we don't want to do, but it has to be done anyway. The backend part, the part that was hard before, now becomes a no-brainer. It was possible because I realized that the single model that I had, the set of classes, was simply not enough. I needed read model. And you can implement read models in many different ways. This is the way that I do it, by using views in the database. It's the simplest thing that is possible, and every view in the database is dedicated for a single view in my application. Views are not shared, views are not reused, because code reused is abused very often. I used simple data just so that I don't have to, use the raw data readers, because simple data is comfortable to use. And my view models, the objects that I'm actually passing to the HTML rendering, they are dynamic. Very rarely, I need to map them to anything else. I don't need dozens or hundreds of C# simple classes just to put something in my HTML. I get something from the database, it is a dynamic, I put it in the HTML rendering engine, and done. I don't need to focus so much on code when I am doing the read side. And I don't have any repository. I don't need it. And why repository is bad? And let me reverse this question and ask you why repository is good. And here are some arguments that people use when they are implementing repositories. They say that repositories are good because then they can mock the repositories in their tests, and test the database integration code in unit test without touching the database. But if you are testing your database code without touching the database, then what are you exactly testing? Some database must be used in tests in order to see if our code is working. Just mocking out the repositories isn't enough unless you test the repositories as well. Instead, you can use in-memory databases, which are really fast and which give you some level of certainty that your code won't break. In more complex scenarios, we, of course, need to test the database itself, the real database, the real heavy database. These tests are slow, and they are not the topic of this talk. So mocking repositories doesn't really give you anything besides the false assurance that your code is working, which you don't know until you run it. Other people say that repositories are good because then you can take your database, your SQL Server, your Oracle, your MySQL, your Postgres, and switch it to another one. And it will be easy because we have repositories. And if someone tells you that, it simply means that he hasn't done it yet. Because it's never easy, it will never be easy. Because it's more than that, it's more than just abstracting our data access code to switch our database engine to something else. There is another argument that repositories are good because then we can switch the object relational mapper, which is used by these repositories. And this is the very big mistake, because if you actually try to find the biggest common denominator of all the ORMs that you want to support, you end up writing your own ORM, or you end up cutting off all the features of the ORMs except the SQL code generation, which, as we talked about, is not perfect, it's not even good. You lose such things as second-level cache, as data validation, as lazy loading, because these things are implemented differently in every ORM. And you cannot simply put some level of abstraction above the ORM, use these features, and expect that another ORM will work with it as well. It won't. And another problem is reusable methods. If we have our repository, like I showed you before, with this get non-archived, advertisements with views count without pictures for user, and a new developer joins the project, and he wants the same data, but he also wants the picture, because he's showing only a single advertisement. And he either writes another method, or he copy-pastes the method that I've written, or he goes to my method, modifies it so that picture is also fetched, and his scenario works, while mine breaks because I load tons of advertisements to show on a single page. Now, when I have my views, if I create view for my scenario, nobody can touch it. People can take it, can copy it, can modify it, but they always create new views. They don't modify mine because my view is perfect for the scenario that I was implementing. Okay, now the right side. What problems do we have with the right side? Well, we have the fat controllers problem. Doesn't matter if you use MVC with real controllers or if we use some other framework that runs our application, there is always this level of framework that wraps our logic. And often, the thing that it wraps is null, because often all logic is put in controllers. And then a DDD expert comes to the company and tells that it cannot be like that. You shouldn't write logic in your controllers. You should do domain objects, domain services, entities, value objects, and so on. And people are really excited about that for a week, for 2 weeks, for a month. They try to do this. So now you have logic, old logic in controllers, new logic the DDD way. And then deadline approaches. And what do people do? What they do best, write code in controllers again. And I'd rather have all my logic in controllers than to have some logic in controllers, some logic in some services, and some logic in repositories. Because now, if I want to understand how the system works, I need to read a shitload of code. I need to read all of this. So the system API is distributed all over the place. It's everywhere. It can be on different layers because there is no standardization. Everything is dependent on everything else. I don't know how about you, but I travel around Poland. I do some consultancy. I do workshops in various companies. And all companies seem to have the same problem, that they have classes that depend on each other, and they are impossible to test. And if something is impossible to test, it's also impossible to maintain, because maintainable code will also be testable code. So how we can solve the problems on the right side? Okay. The right side. We have a new feature. As a user, when I read an ad, I want to have a way to mark it as interesting. Some white star turning into yellow when I click it, so that I can see similar ads, and so that I can maybe go back to this advertisement later, if I don't have money for the Apple Watch now. How would my controller look like? My controller would have an action called mark ad as interesting. It would have two simple parameters: the user and the ID of the advertisement that was marked as interesting. Now, in my controller, I open a Hibernate session, I begin the transaction, I read the user from the database, I read the advertisement from the database, I add the advertisement to the interesting ads collection on my user, and then I save the whole graph. It's very DDD friendly because I have a graph of objects, I have some aggregate root, I load something from the database, and so on. And this is very common misconception of how DDD should look like. Of course, it's in a controller. It shouldn't be in a controller, so I could do some ads service, which would look exactly the same, except that it wouldn't be called a controller and wouldn't inherit from the controller base class. And I have hundreds of such actions in every single service or in every single controller. Now let's get back to the read side for a moment and recall how this feature would affect our query that was showing advertisements to our users. Using this approach that I'm showing, it would be a simple subquery in the row SQL, just a view modification. Select one from interesting ads and join to the users table, join to the companies table, and that's it. Using ORM, it would be another subquery on top of the count that was counting the views count, and it would be more difficult. We need some way to abstract the concept of telling our system to do something. Simple method call is not enough because then we have thousands of methods. Some of them are duplicated, some of them are not. They are very hard to maintain. So we can use something called a command. And a command would be represented by a simple marker interface, iCommand, which is empty. We just use it to make the tooling happy later. We will get to it later. Something has to be done with this command. We need a command handler. So I have an interface, iHandleCommand. It is also simple and empty. Because I need such interface, we will see why. And then we have something with an actual method that's called handle. It's a generic interface, generic command handler, which in its type definition says which command type it can handle. And now we need some way to distribute these commands in my system. And how it is done is actually an implementation detail, but let's see how it can be implemented as an example. My command bus could take a dependency in a form of a function. What I need is some factory that will create handlers for my commands. So I can take a function that takes command type as a parameter and returns me the instance of a handler. And what is important, every command must have one handler dedicated to it. It cannot have 0 handlers, it cannot have multiple handlers. Every command has one single handler. Hence the function definition. And it can be very easily implemented and configured in any dependency injection container, like autofuck, for example. And this is why we need all this marker interface to somehow, by convention, find all commands and all handlers in our system to register them in the container. But here is where the interesting part appears. If we have commands and we have this rule that nothing can be done in our system without creating and without sending the command, then we have a single point in code, the method called sendCommand, that every action will go through it. And when we have such point in code that every action has to go through it, then we can do very interesting things there. We can have aspect-oriented programming without actually having any aspect-oriented tooling or frameworks. We can do some audit logging here. Who issued what command at what time with what parameters? We can do authorization here, transaction management, error management. We can also, which is very helpful, measure how much time every command takes. And it was very helpful in my system when I did some deployment and the client complained that it's working slower than he expects. Then I added this. I started measuring how long any command is executing. And if it was executing more than 200 milliseconds, then I created a separate log file, long-running comments.txt, and I logged all comments there. And it appeared that a single comment type was executing very slowly because I missed some index in the database. So the fix was very simple. When we have our handling code wrapped in with such aspects, then we just take this handler from the factory, call the handle method, and we are done. How the command will look like? The command will look like this. Mark address interesting and the parameters that we need. User ID and advertisement ID. That's it. And the controller. This is where this approach really shines. Because remember how our controllers that were returning data looked like. They only had a single dependency on simple data, dependency on our database. Every controller that does something also has a single dependency. It depends only on the command bus. It takes the command bus as a dependency. It takes the command as a parameter to the action. The framework is responsible for binding the raw data that comes via HTTP and convert it to the command object. And the only thing that the controller does is calling send command on our bus. The command goes to the system and that's it. And the controller returns some OK status. Note that we don't have any exception management here. We don't have any try-catch, because I don't want to have a try-catch in every single action in every single controller. Exception management is done in the send command method, and it's done globally once, and it behaves exactly the same for all my actions. What is also interesting, that now we don't have methods that handle some scenarios. We now have classes, handlers that handle some scenarios. And they are completely independent of each other. So they can be written differently. One handler can use a hibernate and DDD approach. Another handler can focus on performance and on simplicity. This is an example of a handler that focuses on performance and simplicity. Because what is the most performant way to mark and add as interesting by a user? We can add an interesting ads table with 2 columns, user ID, ad ID, that's it. And how do we add the relationship between the user and the advertisement that the ad is interesting for the user? It is just a simple insert. We don't need to load the user object. We don't need to load the advertisement object, then operate on some collection and save the whole graph. We can use simple data here as well. I tell simple data, go to my database, find table that is called interesting ads, and insert some data. In the user ID column, put this value from the command, and in the advertisement ID column, put another value from the command. and it will generate insert values into the table and so on. So it is almost like writing raw SQL, just without the need of using DB commands, data readers, and so on. And there is another mechanism that can be introduced to our system to make it even more pleasant to work with. It is called events. We have queries on the read model, we have commands on the write model, and commands can result in events. Events tell us that something happened in our system. This is the example. User marked add as interesting, so I tell my system, I publish an event which is called add marked as interesting. It is called in a past tense because this is something that already happened. I can't do anything about it. I can add some logic to it. And the whole infrastructure of events is like a mirror image of the commands. We have the iEvent interface, iHandle event interface, generic iHandle event interface, and then we have the events bus, which has a method publish event. And the events bus, again, the implementation is a detail, but it can be done like this, exactly how our command bus was implemented before, with a single difference. Because command, like I said, always must have a single handler, whereas event can have 0 handlers, 1 handler, or multiple handlers. So we need to be prepared for many handlers here. So our function that will create handlers for us returns a collection of handlers, not a single handler. We get all handlers from our dependency injection container, and then in some loop, we just execute all of them. The event looks exactly like the command, but it is called differently. It is called add marked as interesting. We do not reuse the command object because, like I said, code reuse is also often abused. These are totally different concepts, and the code shouldn't be shared between them. And then what can we do if we have such event? When I was writing the code, I had no idea what should happen then. This approach gives me the ability to compile my application, deploy my application, and forget about my application. If somebody wanted to extend my application by telling what should be done, what should be executed when the event actually is raised, he could write a class, a dedicated event handler, deploy it as a separate DLL, just put it in the bin folder of my application, and it would work because of my dependency injection container. So what we can do? When add marked as interesting, we can notify the company. Send some email, hey, this user marked your add as interesting. The company can write its own handler. When add marked as interesting, target more ads towards the user. He will eventually buy something. Or when someone marks an ad as interesting, let's prepare an email campaign for the user. Maybe he will buy something. And what does this approach give us, really? Have you heard about OCP, Open Closed Principle? This is the second principle of the solid principles. OCP, Open Closed Principle, tells us that a component should be open for extension, but closed for modification. Once the code is written and it is working, we shouldn't really touch it until there is some bug. Now we get OCP at the scale of the whole system, because it can be extended by writing new event handlers, by introducing new events in dedicated deployable packages as DLLs. The API of our system, the things that system is doing, is very discoverable, because we can go to the iCommand interface, find all of its implementations, and this is what our system is doing. We don't need to jump around our solution to find every single method, what it is doing. Now, the names of the command classes show us our system is doing this, 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 and this. Great. Our controllers are very, well, thin or stupid. We are as separated from the framework as possible. Each controller action is either a very, very basic query using simple data, or very, very, very basic action which just takes a command as a parameter and sends this further to our logic, which is separate from MVC, from Nancy, from any framework that we use. The problem with current systems today is that we rely on frameworks very heavily. And this approach allows us to quite easily separate our logic code from the framework code. Because all of this that I'm showing you, all of these events, commands, and so on, they can be implemented in a project that doesn't even reference any framework. It is plain, it is simple, and it's separated from any framework that can cause us many troubles. And the handlers that we write, command handlers and event handlers, they become simple. When we have a controller that has thousands lines of code because it has hundreds of methods, it's very hard to maintain. But if we have hundreds or thousands of very small classes, they are quite easy to maintain because most of them will fit on a single screen. Well, I have a 27-inch Dell screen at home, and almost all my handlers fit there. And what is very important for me is that this solution is very extremely testable. Because these handlers are simple, I can test them in separation. Just create an instance of a handler, and that's it. But if I want to do some integration testing and see how everything is wired up, then in the test context, I can configure my dependency injection container, detect all commands, detect all events, wire it up, configure the container, and actually, in my test, send a command using the command bus, and see what happens. Everything should work just as it does in production. So if I want to check whether something was modified in the database, I can do it. If I want to see what events pop up as a result of my command, I can do it as well. And testing CQRS done this way was one of the most fun things that I did in my whole development career, just because it worked and it doesn't require a lot of work. And some examples. When I first used CQRS, I was working on a dialer app. Dialer app means that if you are sleeping at 8 a.m. on Sunday and your phone rings, you answer it and someone tells, hey, don't you need another credit card? Well, they are using the dialer app, such as I wrote. And it was very fun to do until I realized that I am waking people up. And when I was working on it, I had complete freedom, technological freedom. I just got a list of requirements, do whatever you like, use whatever tool you like, and it was the best 2 years of my development life because I was doing whatever I wanted. Fortunately, it seemed to work. But when I was finishing the first release of this application, it was quite a huge system. It took me several months to produce something that can be shown to the client and run in production. The client, 2 days before the big release, told me that he needs something like callbacks. And a callback is that the callback means that our system tried to call someone and the phone was busy. And they want to call this person in 30 seconds or in a minute. When you do an application that works with telephone calls, then if you have a busy signal, then it is the most important validation that you can get, because it means that the phone number is correct, that the phone is registered, that the phone is working, and that somebody is talking through it. So let's try in 30 seconds. I thought that I can't do it in 2 days. It's like a month of work. But then I realized I have my events. I don't even have to touch the code that I already wrote. I realized that I have this event, phone busy, and I can write when phone busy, schedule callback handler. If someone was talking to the phone, I was simply putting this information in some other data store than my whole application was using. So it was completely separate from the core of the system. Then there was only another thing that was left to be done, which is some call selection strategy as it was called, and selecting the next person to be called is quite a complicated process because it takes into consideration if you are dialing a male or a female, how old is he or she, where does he or she live, and it tried to match the person that was dialing to the person that would hopefully answer this. So there were some algorithms, and the most important algorithm became the callback person selection strategy. So it was done. And then they told me that the release can be postponed by several days, but they also want something that is called agent ranking. For some reason, the people that are dialing you, that are calling you, are called agents, and they don't really like working. They can sit at the computer, eat sandwiches, play solitaire, not really calling as much as the company would like them to. So they needed a way to motivate them. So they thought of a ranking that would be updated live on every agent's screen, showing who sold the most products this week and who was the agent number 1. After a week, got some 70-inch screen plasma. And this TV was sitting there in the office. Everybody could see it, and it was really motivating for them. And the sales ratio was much greater than before implementing this. And how it was done. There is the most important event in the system, order taken. I just subscribed to this event and did some logic that using SignalR was sending some information to each browser because it was a web app that caused some HTML table to re-render the agent ranking. And it was done during one night. Something similar could be done as a reward for people who talk to the customers. There may not be the best salesman, but they try to do it. So there is the phone answered event. If somebody is really trying, is dialing, is talking, but it's not selling, well, we don't give him the TV, but he maybe can control the music that is played when someone is not talking. And I would be very motivated by that, to put some behemoth in other people's ears. And the problem with CQRS is that it can be really great. And I tried to think of scenarios where CQRS would not be recommended, and I couldn't think of any. So I Googled, Udi Dahan, when not to use CQRS. And I stumbled upon .NET Rocks podcast, where Udi was a guest, and he tells the podcast hosts that you shouldn't treat CQRS as architecture or as a silver bullet because it has its costs. If all you need to do is some CRUD, create, read, update, delete, some basic applications, that maybe you don't need CQRS there. Also, CQRS may not be the best way to solve problems when you have a so-called single user domain. And an example of single user domain is a blogging platform that has multiple authors, but if the post is saved as draft, only the author can see it. There is no concurrency there. There is no fighting for resources. Such drafts can be even saved in a different data store or even in a different format. It is also a simple CRUD. The most important lesson from these two scenarios is that CQRS shouldn't be viewed as a way to solve problems system-wise, but only the most important problems that can appear by some performance issues that we have in our application. Then CQRS can help. So let's summarize. When we divide our application into the read side and the write side, when we have the read model and the write model, the difference is very obvious. That the read side is damn simple. Simple SQL query, simple view, very simple controller, and then the HTML and styling and so on. So it can be done by inexperienced people, this can be done by juniors, or this can be done by seniors that are on hangover. And this is not where we should focus when we write our applications, because it is very simple and it's very easy to rewrite. We should focus on the right side, on the state modification, on domain logic, on business logic. This is where we put our senior people. This is what we test. This is where we do code reviews, and so on. So how we split work between people also becomes much easier. And this is in Polish, but no, this is not in Polish. This is in English too. I asked Udi Dahan to record a podcast episode with me about CQRS, and I recommend you go there and listen to it because it's something, it's a different phase of CQRS. It's a different approach. Udi talks from the business perspective, not from the developer's perspective. And this is almost everything, but I have a short announcement. I don't see any organizers, maybe I won't be punished. I'm doing a testing workshop in Warsaw on 18th of November. And if you want to register, well, first, you'd better hurry. And second, if you use the NetDD discount code, it will give you a total of 35% discount on this training. So thank you. And do you have any questions? Yeah? Oh, makes me happy. Yes?
I have an additional microphone.
Okay, hello. So
Hi.
my question is, you have those events and you said that one type of event gets one handler. So what in case that you actually have some event like phone busy and you actually handle it some way and then requirements changes and you would like to do some additional work that is unrelated to the previous handling?
One command has one handler. An event can have multiple handlers. That's the difference between commands and events.
Okay, that explains a lot.
Okay.
You said that a read site should be as simple as possible, but
Yes.
what do you think? Is it a good idea to use the same approach as for commands, to have a iQuery interface and iQuery handler?
I tried to do it, and it just adds an unnecessary level of abstraction. Because in my systems, every query is used only once. Like I said, each view is used only once on a single scenario, so that all scenarios, all screens in my application can evolve separately.
Okay.
So I don't need any interface because if I could, I would just hard code the SQL query in my Razor file.
But if you need some additional events, for example, someone viewed the page and you modify the data somehow, for example, count, do some statistics, do some measurements or something like this.
Well, some statistics, every framework that is there allows you to plug into the pipeline of the request. So you can do all the statistics, not on the controller level, but on the framework infrastructure level. It shouldn't be done in controllers anyway. Oh.
Hello.
Hi.
If I understood correctly, you encourage to use, of course, in certain situation, more than one ORM. So in your examples, I saw an Hibernate and simple data. And also you had views in your database. How do you handle actual model change and upgrades?
Well, I don't have a single model, so I don't have model changes per se. I can have changes in my database.
Just to specify, how do you handle the change of your database schema?
Change of my database schema, well, then I would update all the views that are affected by it.
So update and Hibernate mappings, update
No, I
simple
don't
data?
have any Hibernate mappings because I don't ORM. I don't use ORM.
Oh, no ORM at all.
Only simple data. Yes, for like 4 years now, and I'm very happy.
So even for CRUD, just simple data.
Yes, that's how I do it. Because ORMs, well, they have a lot of problems, and all the benefits that they give me, I can do it by hand much quicker.
Okay, thank you.
You mentioned several times about the commands, the handlers. So it's generally the command pattern.
Yeah.
You also mentioned how can we use AOP in such manner with the events and the event handlers. I'm curious just how can we implement that? Like, let's say PostSharp give us visibility, how to implement AOP for caching, for logging on other stuff. How can we do it with the command pattern?
Well, I have this command bus that has this single method that everything goes through it. So I know AOP, but I am not very big fan of it because it hides the code that is executed, and then other people don't know where to look for it. If I have some aspects written as PostSharp aspects or as some autofuck interceptors, it is called, where it's hard to find them. If I have everything in a single method, I know that it breaks some OOP rules, but it is just the most simple thing to do, and it works really well because I don't have as much there as you could think. It is also a single screen.
Thanks.
To z przodu są.
And what if we could not use view, for example, for complex maintenance and for case when it could be criteria that we could not predict? If we could not use view, is it other solution for read?
Sorry, didn't get that.
If we could not use view in database, is there any solution?
If we do what with the view?
If we could not use view.
A lot of views? Well, why would be an issue? It could be an issue if you have materialized views, all of them, and then they would have to refresh. But
sometimes we don't know all criteria we could use. And sometimes it's difficult to maintain if there are many.
Well, I didn't approach this problem. I didn't have this problem. I have multiple views. Everyone is. The clue is that every view has to be dedicated for a single screen, not share views between scenarios.
But if you don't know all criteria, if you could not create views for all cases you have.
If I couldn't create views, but why? Because some database guy tells that I can't?
It could become a million views or something for all cases, for example. You did not have.
I would feel offended.
Okay.
Okay. You have one more here?
Hello. So you gave it an example with trying to do something in Hibernate, then it took a lot of time, so you said, okay, I have already a SQL code, I can just use that, and you did it as in the view. And that's what you advised. So wouldn't it be pushing, or it would be actually pushing, complexity from the code to the database?
Well, no, because these queries are simple if you write them as SQL queries. They are complicated if you are doing ORM.
So what if they are not simple?
Then I would probably use repositories, which I don't like. But I'm talking about applications that use relational databases. If it's not SQL, then I don't know.
No,
it depends.
It might be SQL, but SQL give you actually quite good support for complex data. And if you have complex data, then because of performance, it have to be different than your domain model or business model. And then the report, if you create, that may require different entities from the business model. And somewhere this complexity have to be. It can be either in the application, either in the database.
If I have complex logic to get some data from the database and it cannot be done by a view, then I do a repository with interface with a single method that tells me that this is a data access for this single scenario. So I don't do repositories like, I don't know, with 50 methods, but if I have to do repository, like in the scenario that we are describing, then I have a repository with a single method, never more. So it's just like, you know, data fetcher, maybe, for a single scenario, not a repository.
Okay, and the second thing, if you have this command pattern, then to check what are the possibilities of the service, so what commands you have to go to the service, the code, and check it. Yeah? But when you expose it to the world, then I, as a consumer of this service, I would like to know what it can do for me. So if there is no a contract like you have, for example, in simple WCF or something like that, then how you do it? How do you expose it?
Using controller actions. This is a normal API.
Okay, so you have, on top of this, you have anyway normal controller.
I have some framework, yeah, because I want to write my execution engine that will host it. I have something that hosts this, and every command can be either documented and sent by name to my system, and my system figures out what command is it, or I have a separate controller action exposed to the whole world to use. It's one action for one command.
Okay, so what actually is the role of this I command? What it gives you? What's the benefit?
It depends how you host it. If you do it as a REST service, then you don't send me I commands, you send me some text. And my hosting engine takes care of binding it.
So then you have to translate from what you got from the client to something that your pattern can consume. And
my framework takes care of binding what I got from my client to my command. My client has to send me something in a specific format that can be translated into a command that I require.
Okay, so what is the main benefit of this command then? Because you can do it without the command, you can have the same, yeah?
The interface, I command?
You can have the same communication without this I command, this command.
Yes, I told that I command interface is only to make dependency injection configuration easier.
Okay.
That's it, yeah. Okay, so let's stop here. Please catch me during the break, and thank you.